In this lesson, we'll be looking at solving simultaneous linear and quadratic equation using the almighty formula, as we call it. Rather, it is called the quadratic formula. S equal to minus b plus or minus the root of b squared minus 4ac all divided by 2a. For the quadratic equation ax squared plus bx plus c equal to 0, where a, b, and c are scalars. For example, solve the pair of equation y equal to 2x minus 3, equation A, and x squared plus y squared equal to 2, equation B. Solution. Substitute equation A into equation B. We'll have x squared plus the square of 2x minus 3 equal to 2, which will further give us x squared plus 4x squared minus 12x plus 9 equal to 2 when we expand the bracket, which will give us 5x squared minus 12x plus 7 equal to 0 when we collect like terms. Compare these to ax squared plus bx plus c equal to 0. We'll find out that a is equal to 5, b is equal to minus 12, and c is equal to 7. Remember the formula x equal to minus b plus or minus this root of b squared minus 4ac all over 2a. Substitute the values into the formula. You have x equal to minus 12 plus or minus the root of the square of minus 12 minus 4 times 5 times 7 all divided by 2 times 5. We'll have that x is equal to 12 plus or minus the root of 144 minus 140 all over 10. We'll have x equal to 12 plus or minus the root of 4 divided by 10, which will give us x equal to 12 plus or minus 2 divided by 10. Either x is equal to 12 minus 2 all over 10, such that x is equal to 10 over 10, which implies that x is equal to 1, or x is equal to 12 plus 2 all over 10, such that x is equal to 14 over 10, which implies that x is equal to 7 over 5. From equation A, find the corresponding values of y. Equation A is y equal to 2x minus 3. So for x equal to 1, y will be equal to 2 into 1 minus 3, which implies that y will give us 2 minus 3, which implies that y is equal to minus 1. And for x equal to 7 over 5, y will be 2 into 7 over 5 minus 3, which implies that y will be equal to 14 over 5 minus 3, which implies that y will be equal to minus 1 over 5. So what you should be looking at here is the sign. Note that when minus a number will give us plus, and the square of a negative number will turn to be positive. Sometimes it is possible that a system of simultaneous equations do not have a real solution. This is seen in the discriminant test. The discriminant test b squared minus 4ac. If it turns out to be negative, it means that such equation has no real root. Remember what we did in quadratic equation when we learned quadratic equation sometimes last term. We investigated the discriminant to see what happens when it is positive, when it is 0, and when it is negative. Then If such happens in a simultaneous equation, such simultaneous equation has no solution. Let us look at this example. Solve the system of equation y equal to 2x plus 12 as our equation 1 and y equal to negative x squared plus 2 as our equation 2. Solution: substitute the value of y in either equation. Since both of them y is made the subject formula, so we have 3x plus 12 equal to minus x squared plus 2. This will give us x squared plus 3x plus 10 equal to 0. Compare with ax squared plus bx plus c equal to 0. We will find out that our a is equal to 0, b is equal to 3, c is equal to 10. Before we solve, let us run the discriminant test. B squared minus 4ac will give us 3 squared minus 4 times 1 times 10, which implies that which will give us 9 minus 40, which gives us minus 31, which turns out negative. So there is no real solution to such simultaneous equation, since the square root of minus 13 is not a real number. This is clearly seen when it's plotted in a graph. You see that the straight line in equation A has no place. It cuts the quadratic equation in equation B. So such a quadratic equation is said to have no solution.